Now proceeding from that equation only, as you have seen, beta equals to q2 upon w. q2 upon w means heat rejected upon the work done, that is q2 in terms of heat energy, q2 upon q1 minus q2. This can also be right in the form of the temperature, that is beta equals to T2 upon T1 minus T2. Now we can see how it can be written in this form. The procedure is this: Q1 equals to W plus Q2, which is equals to W equals to Q1 minus Q2, and this Q2 upon W, in place of W we can write this value and if dividing both the equation by both the sides by q2, so it becomes q1, and this q1 upon q2, and here q2 upon q2, that is equals to 1. Now as we know, q1 upon q2 is equals to t1 upon t2, so from this equation it is 1, and in place of q1 upon q2 we can write t1 upon t2 minus 1. From here you can see this from here. So ultimately solving, we are getting beta is equals to, which is the coefficient of performance, T2 upon T1 minus T2. So this is the ultimate formula for this. Now let us see, we will do one problem based on this only, refrigerator. So let us see what is the problem. It is given in a refrigerator, heat from inside at 277 Kelvin is transferred to a room at 300 Kelvin. How many joules of heat shall be delivered to the room from each joule of electrical energy consumed ideally? And the options are 1, 2, 3, 4. So let us see. Is correct answer is 13 joule. We will see that. So now we will see the solution, how it will be solved. देखिए, from the question that is clear, it is given the heat of 2, that heat is rejected from the refrigerator. This is the concept, and then it goes to the room, that is Q1, and rejected heat is Q2 from the refrigerator, and refrigerator is at the temperature 277, which is already written here. Refrigerator heat from inside 277 degree. From here it is transferred to the room of 300 K. It means temperature of the room, that is the 300 Kelvin. So this picture is clear, and the amount of electrical energy which is providing per second, that is 1 joule. It is mentioned over here. It is asked the each joule of electrical energy consumed. It is consuming 1 joule of electrical energy. Then it is asked how much heat will be given to the room. So from the equation we know that Q1 is equals to W plus Q2. So W plus Q2 is this, and we know the beta coefficient of performance, W Q2 upon W. Q2 is as it is, W can be written from this way, from this equation. So finally we know we can convert this T2 upon T1 minus T2. We put all the value and simplify. It is coming approximately 12 joule. Now as we know, beta equals to Q2 upon W2, that we have written here. From here W we will send on this side, so we can calculate Q2 is equals to 12 into W. It means the Q2 amount of heat that is drawn from that refrigerator is 12 joule. So overall heat supplied to the room Q1 is equals to sum of these two. So that is W plus Q2. W is given 1 joule, and that is already have come 12. So ultimately 13 joule will be rejected, and your option is 12 is correct. Okay.